Okay, so problems 7 through 10 are kind of the challenge problems. They're the exact same concept, but they are harder than the ones that we've done so far. So we're going to start out the exact same way. We're going to break them down into the elements that make up each of the compounds on the reactants and the product side. So first on the reactants, we have iron, which is Fe, sulfur, which is S, and oxygen, which is O. And then the exact same thing on the product side. Remember, regardless of the way that they're ordered, make sure that when you're listing the elements, you put them in the same order on both the reactants and the product side. It makes it a whole lot easier to compare. So now let's look at what number of elements we have, or number of atoms of each we have. So we have 1 atom of iron, 2 atoms of sulfur, and 2 atoms of oxygen on the reactant side. On the product side, we have 2 atoms of iron, 1 atom of sulfur, and this is where it gets more complicated because we have oxygen in both of the compounds in the products. So in this compound, we have 3 atoms of oxygen, and in this compound, we have 2. So we have 5 total atoms of oxygen. So let's start with iron and balance that one first. So we have 2 atoms of iron on the product side and 1 on the reactant side. So we're going to put a 2 in front of the FeS2, which gives us 2 atoms of iron on the reactant side, but it also, remember, applies to the sulfur in that compound. So we now have 4 atoms of sulfur on the reactant side. On the product side, we only have 1 atom of sulfur. So we need to put a 4 in front of the SO2 to give us 4 atoms of sulfur. But again, that changes the number of atoms of oxygen in this compound. So instead of 2 atoms of oxygen in this compound, we now have 8 because there's 4 molecules of SO2. Each of those molecules has 2 atoms of oxygen. So there's 8 total atoms of oxygen in this compound. So we have 8 plus 3, which is 11 total atoms of oxygen on the product side. So the iron and the sulfur are both balanced, and the oxygen is not balanced at all. So what we want to do is get it balanced. The easiest way to do that would just be to put a 5.5 or 5.5 in front of the O2, right? Because that would give us 11 atoms of oxygen on the reactant side as well as the product side. The problem is you can't have a half a molecule of oxygen. You can only have whole numbers as coefficients. So what we need to do is take this entire problem and multiply it by 2. So that means that instead of a 2 here, we would have 4 FeS2. And instead of the 5.5, we would have 11 O2. Then we still have the arrow for the chemical reaction. And then since there's basically a 1 right here, since there's nothing, remember that means that there's a 1 for a coefficient. We would have 2 Fe2O3 plus, instead of 4 times 2 is 8 SO2. So then if we go back up here, I'm going to use a different color to make it a little bit easier to see. We now have on the product side, or on the reactant side, we have 4 molecules of iron, or 4 atoms of iron. We have 8 atoms of sulfur. We have 22 atoms of oxygen. And over on the product side, we have 4 atoms of iron, 8 atoms of sulfur, and then again, we have to figure out the oxygen. So we have 2 times 3 is 6 atoms of oxygen in this molecule, and 8 times 2 is 16. So if you add 16 and 6, that is 22 atoms of oxygen on the product side. So now you can see that it's balanced. So this is what your balanced chemical equation would look like. For number 8, this one's a little bit easier. Number 7 is probably the hardest one on here. So for number 8, you're going to do basically the same thing again. This one, again, is more complicated because you have hydrogen in multiple places. So we have P, which is phosphorus, Cl, chlorine, H, hydrogen, and O for oxygen. And then again, the same thing on the product side. I'm going to put them again in the same order that I did the reactants. So PClHO. So on the reactant side, we have 1 phosphorus, 5 chlorines, 2 hydrogens, and 1 oxygen. On the product side, we have 1 phosphorus, 1 chlorine, 1 hydrogen here, and 3 hydrogens here, so 4 total hydrogens, and 4 oxygens. So the phosphorus is balanced. We're going to leave that exactly like it is. The chlorines are not. We need to fix that. So there's 5 on the reactant side and 1 on the product side. So if we put a 5 in front of the HCl, then that changes the chlorine to 5 atoms of chlorine. But again, remember, it changes the number of hydrogens. So now in this compound, HCl, we have 5 atoms of hydrogen. So we have 5 atoms of hydrogen over here and 3 atoms of hydrogen over here, which means that we now have 8 atoms of hydrogen total. So we're going to leave hydrogen by itself for now and come back to that. Right now we have 1 oxygen, or we're going to leave the hydrogen alone for now. We'll come back to it. So oxygen. On the reactant side, we have 1 oxygen, and on the product side, we have 4. So in order to fix that, we need 4 oxygens on the products, or on the reactant side. So we're going to put a 4 in front of this water molecule, and that gives us 4 atoms of oxygen, just like we need. It also solves our problem with the hydrogen, because 4 molecules of water means that we have 8 total hydrogens. So now that one is completely balanced. Number 9 is, again, a little bit more complicated because we have oxygen on both sides, but again, it's not as hard as number 7. So let's break down the elements that we have. We have carbon, hydrogen, and oxygen on both sides. And on the reactant side, we have 3 atoms of carbon and 8 atoms of hydrogen and 2 atoms of oxygen. On the product side, we have 1 atom of carbon, 2 atoms of hydrogen, and in carbon dioxide, we have 2 atoms of oxygen, and in water, we have 1. So we have 3 atoms of oxygen total on the product side. So first, let's solve for the carbon. So we have 3 on the reactant side and 1 on the product side. So we're going to put a 3 in front of the carbon dioxide, the CO2. That means that we now have 3 carbons, and we no longer have 2 oxygen atoms right here because we have 6. There's 3 carbon dioxide molecules total. Each of those 3 has 2 atoms of oxygen. So there's 6 total oxygens right there, which means that we have 7 total because there's 1 in this water molecule over here. So 7 atoms of oxygen. Now let's fix the hydrogens. We're going to leave oxygen till last this time because there's an O2 right here by itself. So if we fix the hydrogens, we have 8 on the reactant side and 2 on the product side. So we're going to put a 4 in front of the water molecule right there so that we have 8 total atoms of hydrogen, because in those 4 water molecules, there are 8 total atoms of hydrogen, 2 in each of the molecules. That also changes the number of oxygen molecules that we have, or oxygen atoms that we have in water. So we have 4 total oxygen atoms in the water, and then we still have those 6 from the carbon dioxide. So we have 10 total oxygen atoms. Now, this is a pretty easy fix because we have 10 over here and 2 on the reactant side, which means that if we put a 5 in front of the oxygen, we now have 10 oxygen atoms on the reactant side. And that one is balanced. The last one is an example that we've done before, and that is, or that you should have done before on this worksheet. So this is the reaction for cellular respiration. C6H12O6 is glucose plus oxygen, gives us carbon dioxide and water plus energy. Remember, when we're doing balanced chemical equations, energy does not factor in. Energy is not made of atoms, so it's not technically a product or a reactant. So we can completely ignore that. But we do still need to deal with all of the actual elements. So again, C, H, and O are the three elements that are on the reactant side. They are also the 3 elements that are on the product side. So on the reactant side, we have 6 hydrogens, 6 carbons, 12 hydrogens, and then 6 oxygens here and 2 oxygens here, which means that we have 8 total oxygens on the reactant side. On the product side, we have 1 carbon, 2 hydrogens, and 2 oxygens here and 1 oxygen here, which means that we have 3 total oxygens on the product side. So let's solve for carbon first. So carbon, we have 6 on the reactant side and 1 on the product side. So if we put a 6 in front of the carbon dioxide on the products, that gives us 6 atoms of carbon. So the carbons are now balanced. But it also changes the number of oxygens that we have. So instead of having 2 oxygens right here, we now have 12. So we have 12 total oxygen atoms in those carbon dioxide molecules. So we have 12 here and 1 here. So that's 13 molecules of oxygen, or 13 atoms of oxygen on the product side. Now let's solve for hydrogen because, again, we have oxygen all by itself right here. So we're going to leave that until last. So if we do hydrogen next, we have 12 on the reactant side and 2 on the product side. So in order to make that balance, since we have 2 right here in the water molecule, we're going to put a 6 in front of that. 6 times 2 is 12, so we now have 12 hydrogen atoms on both sides. But again, that changes the number of oxygen atoms as well, because there are now 6 oxygen atoms in the water. So we have 6 atoms of oxygen in the water and 12 in the carbon dioxide, which means that we have 18 total atoms of oxygen on the product side. So in order to fix that, we have to figure out how to make it work over here. So we have 6 atoms of oxygen in glucose. We also have 2 atoms of oxygen in water. The easiest thing to do is to leave these 6 here since they're connected to carbon and hydrogen, which we've already balanced, and just make it work with this oxygen if we can. So what we're going to do is we're going to say, okay, we have 18 total oxygens that we need to make that we need to end up with over on this side. 6 of them are in here, which means that we have 12 left over that we need to deal with. So if we need 12 oxygens on this side, the way that we're going to do it is to put a 6 right here, which changes this from 2 oxygens to 12. And then 12 plus 6 equals 18, and we now have 18 oxygen atoms on both sides of the chemical equation now also. So this one is now balanced. If you feel comfortable with all of this, move on. There's some more practice problems on the next site. If not, go back and watch the videos and practice some more.